Hi all, in this project we built a model to predict the electrical energy output of a combined cycle power plant which uses a combination of gas turbines, steam turbines and heat recovery steam generator to generate power. We have set of 9568 hourly average ambient environmental readings from the sensors at the power plant which we will be using in our model. So yeah, so the mission statement is what we will be doing in this next couple of minutes is we will be going through a couple of steps, which is basically to create the model so that it can predict the hourly energy output, evaluate the performance of the model, and then finally deploy the model for testing. Now, why we need this model first of all? See, the reason for this is to accurately predict how much energy a power plant can generate is crucial when planning out the supply and demand a city might need. Now, if done correctly, inaccurate predictions could result in the rise of per unit cost of electric power, power outages, and lot of other unplanned difficulties. So, what we are doing now for this exercise is we have a data set which is basically in a CSV format, and the data has been collected over the course of last 6-7 years and has some data points of 9568. The columns in the data are basically consist of hourly average ambient variables, which is in the AT column, the ambient pressure, the AP column, the relative humidity, the RH, and the exhaust vacuum, which is in the V column. We will be predicting the net hourly electrical energy output, that is the PE column. For this whole exercise, I'm using Google's AutoML platform called Google's Vertex AI, which is a low-code machine learning platform that makes it much easier for developers to deploy and maintain their AI models. To start the work, there are a couple of workflows or a couple of steps which we need to perform, which starts with exploratory data analysis, then develop the model, evaluate the model, and finally select the best model. Now to start with the exploratory data analysis, what I did was I took the CSV and uploaded into the Vertex for further exploration. With over 9,000 rows and around 5 numerical features, um, we noticed that there was no missing data and the cleansing was quite easy and very straightforward. After reviewing the data and getting familiar with it, I went ahead and also started working on the configuration of the model. So as I mentioned, the data set is very simple with a lot of numerical data. It is no brainer to select something like linear regression for the prediction. It will be the most useful model when it comes to the numerical data, as we all know. So for this topic, for this chap project, I choose the linear regression for the reason also below is because it is very easy to manage or configure. It is very easy to understand when it comes to relationship between input and output data. To train the model, there are a couple of things which we need to perform, and what I started was I basically inputted, I selected the model basically with the input data, and I selected the objective as the regression. In the second step, it basically is this area where I have selected the target feature and splitting the data. Now, the nice thing about this is it was also asking me which column, and I have selected the net hourly electric energy output because this is what we are trying to predict. So the PE is my target column. And if you notice, the AI platform automatically splits the data into the test data and the training data. So what I did was I tried and did this combination of the configuration couple of time to see the strong correlation between one of my input features. After this, it was very evident that the column 80, the ambient temperature, is one of the most important feature when it comes to correlating with the target output. Now, once we did that, uh, it was more of like going with this column. It was very clear. So the next step was to adding a weight for this important feature. With that, I decided to weight the 80 column more than the other model feature input because it was very clear. And in order to measure the model errors appropriately, with an effort to penalize large errors, uh, in particularly, I choose to go with the root mean squared error, which is RMSE. For evaluating, there were many things which we have, and there were a lot of model error metrics available. For example, the mean absolute error, which is MEE, and then we have the mean absolute percentage error, we have the root mean square error, and root mean squared log error. So all this helped in identifying which is the best model, and finally I have decided to go with the RMSEs because the RMSE uh, uh, because it is basically not too high. The result was not too high, or the it's too low. So I went ahead with the model deployment process. For deploying the model, there are certain things like the endpoint name. So we need to create the endpoint so that we can generate the model. There are few steps which we need to perform, like creating the endpoint, getting the endpoint, and finally deploying the model to the endpoint. It took almost around 10 minutes, and after 10 minutes, we have the results in hand, where we I have basically tried and again going back and checking the data for the column, yeah, for the testing part, where I have gone ahead and added the data for the column VAPRH to see what is my predicted value coming from the model versus what is my targeted value. And the result is very clear. The model has predicted very close by almost, I would say, 95% confidence. The results were very close by, with an error margin of somewhere around 4.8. Though the model looks quite overfitting, but this was my first model, so it worked very well for me. And I'm very happy to say that with 95% prediction interval, the model has really done a great job. So thanks a lot for listening to the video. Thanks again.